sure this will work or not. When I take a look at functions of this fashion, what I notice is that I can't differentiate him like I normally would. Because I've got the square root of x, I don't have the square root of 5x plus 1. What do I do? This is in what we would call in college algebra a composite function. You have an inside function, which is 5x plus 1, and you have an outside function, which is the square root. This is a function that's comprised as two functions. It's a composite function. If I were to look at x squared plus 1 to the fifth, I notice that, again, I have an inside function. The inside function is x squared plus 1. And the outside function is this guy raised to the fifth power. Now, chain rule says this. If you have a function that is a composite function, this is h composed with g, that says the inside function is g, the outside function is h. So it's h of g of x. Then the derivative of that composite function is the derivative of the outside times the derivative of the inside. The derivative of the outside, now notice the inside is kept intact. I ignore him. I don't care what he is until I have to differentiate him. To me, the inside, in my own little mind, the inside is a blob. This is where that factoring worksheet thing comes into play when we go to simplify. The inside times the derivative of the outside times the derivative of the inside. So that when I look at this one right here, this is my inside. So what am I going to do? It's going to be the derivative of the outside function times the derivative of the inside function. I don't care what's inside until I have to write it. So the derivative of the outside is 3 times the blob squared times the derivative of the blob. And what's the derivative of the blob? Blob is 5x plus 2. Derivative of 5x plus 2 is 5. And then this becomes 5x plus 2. Derivative of the outside times derivative of the inside.
So is that always going to remain the same, 5x plus 2?
Mm-hmm. I don't care what's inside. When I take the derivative of the outside, I could care less what's on the inside because I'm only dealing with the outside of the package. I don't open that package up. It's as though that this guy basically is a package. He's closed. When I take the derivative of the outside, care not what's on the inside. So I take the derivative of the outside as though I just had that single function, x squared, or in this case, x cubed.
Why is it 5x plus 2?
Oh, it should be minus 2. And then simplifying would be 15 times 5x minus 2 squared.
So taking the derivative of the first, the blob, and then the 3 is just bringing down the power to 2.
That's just power rule.
That's just power.
That's as though all I had was x cubed.
Okay, but you don't bring like 3 to the front of 5, so it would be 15x. Oh, I see, 15. I see, okay.
Now I rewrite this guy as 5 times 2x plus 1 to what power? And that's so I don't have to use quotient rule on him. I could use quotient rule, but I don't want to. But I don't have to. If that's a constant on top, I can just rewrite it that way. So what would f prime be? Well, it's 5 times the derivative of the outside. Don't care what's on the inside. Times the derivative of the inside. As far as I'm concerned, when I take that first derivative, he has no inside. To me, it's a blur. That's why I call it a blob. So, this is 5 times negative 4 times the blob to the negative 5 times the derivative of the blob is
2.
So this becomes minus 40 times the blob to the negative 5, and the blob is 2x plus 1.
And then the 2 drops out because it's a constant.
Pardon me?
The 2 at the end drops out because it's a constant.
Well, no, you multiply him together. So you've got 5 times negative 4 times the blob to the negative 5th times 2. So 5 times negative 4 is negative 20. Negative 20 times positive 2 is negative 40. So they're just all multiplied together so far.